Hello, and in this short workshop video, I'm going to introduce you to a couple of packages in R which are really useful for accelerating your mesh processing. These will mainly be the package RVCG, which is basically a command line version of the main functions of MeshLab, Morpho, which has a lot of helpful functions for cleaning up scans that you might not realize about, even though it's primarily a geometric morphometric package, and also the RGL package, which is really good for displaying your data in a 3D fashion and generating really nice illustrations for publication. So what the format of this will be is I'll go through the basics of R, getting the package up and running, getting some software into the environment, getting some software and some models into the environment, doing basic manipulation of the meshes one by one, and then at the end of the workshop I will also show you how to apply all of these functions as batch functions, so that you can process something like 50, 100, 200, 1,000 meshes all with one short set of code, saving you a lot of time. And as we know, this is what we really want to use R for, is for the automation. So without further ado, I will start up R and get you guys familiarized with the various commands, and hopefully this will really help you to explore R with a bit more confidence. All of the code that I use in today will be on my GitHub, which will be in the description of the video, and I will also put the 3D models that are used in this workshop on the same GitHub repository, so you can replicate exactly what is done in this workshop for yourself on your own machines if you wish to. So when you start using R for the first time, you will come across So one of the first things I would recommend for those who are going to try using R for data analysis, mesh processing, or anything like that, is to use a version called RStudio. So RStudio is what's called an interactive development environment. And what this actually means in short is that instead of just having the main console, which is this part here, which can be quite intimidating, where it just shows you your code and what you're typing in, it also has things like an environment, which shows you the files that are loaded in, or the variables that are loaded into R. It has a history tab, so anything that you've typed, you can go and look for that command, which is very useful. It's very common for you to spend ages fiddling with a piece of code and finally getting it right, and then going, which one was that? And you can go back to the code in your history, which is a bit easier to navigate than the console. And you can search for the code and it will pull it up, and you can run it again and check it works nicely for you. You also have things called connections, which is where if you're connecting to a remote server for R, if you're doing large jobs, this will show what you're connected to. In your console and the terminal, you have two different views. I tend to just leave it as the console. Then in this right hand corner, you have things which make your life a lot easier. So here we have the files folder, and I've navigated to the folder already for the mesh processing scans, but I'll show you how to navigate to a folder where your data is, so that you can work in that directory without having to worry about finding it all the time. You have a helpful thing called plots, which any 2D plots you do will show up here. Packages lists all the different packages that you have. So R works by using packages, which are like little snippets of software which help you to do tasks. Some of them can be very basic snippets, and some of them can be quite advanced, like the morpho package. You also have a help menu, and then there's a viewer as well. The help menu is really great because you can search all of your packages all at once for something. If you can't remember quite which package it was and what the specific command was, you can also then within results or within the page you've already got open look for something, which can be really useful if a function is quite involved. So what we're going to do is I'm going to show you two ways to load a package in RStudio. So the first one is using the console. So I have these packages already installed, but I'll show you how to install a package and load it. So we're going to install RGL, which is the basic package we use. And if you actually remember the functions properly, it's install package is RGL . Now it's installing it for you. It's downloading it, saying it's all downloaded in the package. Now to load this, I type in library, which is a bit confusing because you'd think it would say loads package, but it likes to use the term library. So it's library RGL. And you can see I can't type this morning, so it's now loaded the package RGL. So that's a nice way to do it. And if you know the names of your packages really well and you're confident just typing all the time, that's really nice. In RStudio, you have the option also, when you go to the package window, to scroll down to the package that you want. So I'm going to scroll down to Morpho. As you can see, I have a lot of packages loaded. So, and then I just click on the tick box and it loads it for me. So we're going to do the same with RBCG. And we have these three packages loaded. Now, you'll want to maybe save these routines. So what you do now is you go up here and you see there's a new button. If you click there, you can have an R script, notebook, markdown, shiny web apps. That's if you're confident you can make a package where other people can just point and click the function in R. Or you can do all these different things. What we're going to do now is just go for R script. And this pops open another window. So what I'm going to do is I'm going to copy those three things. Just remove the small greater than sign. And what this will do when we have this script is it will tell us to load these packages. So to tell us, we always try to leave comments in code to make it helpful for both future you and also any other users you would do. So here it says, I will say, load these packages. And you start this by having a hash key to tell R that it's a comment and it shouldn't try and run that as code. So we've loaded these three packages. That's great. That's the first nice, easy bit done. The next thing to do is to get some data into R. So if we click to the Files tab, we can see we have 4 files here. So we have a mandible, a skull, they're both human, both from Sketchfab, a region of interest segmentation of some trabecular bones from a paper I worked on, and then this segmented out spinal column, which is available from my Sketchfab. All of these will be on the GitHub repository. So I want to get the skull into R. So I'm going to go into the script editor rather than working on the console, because that means it's easier for us to save the data afterwards and save the script. So what I would do here is I would use a function called file to mesh it from Morpho. So this, we just type in just do this, and then we press Control Enter. If you're using a Mac, it's Command Enter. What this has done is it has loaded a file in, but I've made a mistake. All it's done is loaded, but it hasn't appeared in the environment, because what I want to do is actually give the variable a name. So we're just going to call this example skull, and we do an arrow to it. Press Control or Command Enter, run the thing, and we see it's now in the window. So that's nice. What's the skull look like? Is it actually any good? So I want to have a quick look at this. So this is where the RGL library is really nice. So I'm going to go use the command. So we'll just make a comment on that. Load in example skull. And I want to show this. So I'm going to have this skull appear. So I want to put shade 3D, and I want it to be example skull. And I'll go enter. This will pop open as a separate window. And you can see that the default shading in RGL is a bit wacky sometimes. So I want this to actually be in a nice color that I would actually recognize as maybe bone. So there's two ways you can do this. So what we're going to do first is we're going to just split screen on this. We're going to remove this from the RGL window. So there's a very handy function called RGL Pop. And you just do that. Just run that. And it removes the last object that you loaded into the environment. So I'm now going to shape this in a different color. Let's go light blue. So what we do is light blue. And you have to remember to put col equals. It's going to bring it up, and here we are. And you can see this is quite a nice segmentation. It's been cleaned up by the original person using Blender and ZBrush, and it's quite nice and clean. It's just the outside of the skull, which we'll see in a second when we do another thing. So we're going to go RGL Pop again, because I want to make this a transparent skull. So I copy and what you use, the term you use for transparency of objects is one called alpha. So alpha equals, and I usually put 0.4. So it goes from a scale of 0 being totally transparent to 1 being totally opaque. So alpha 0.4. This does take a bit more memory on your computer, so you need a fairly decent computer to run it when you have multiple objects. But you can see that this is a small, a solid skull. It's all been filled in internally, but it's a very nice illustration. So, okay, I have this nice illustration, which might be nice for, you know, a teaching aid to show people what it looks like. So to do that, what I would do is I'd go RGL snapshot, then I will give it a name, transparent skull. Just doing it. And here is our transparent skull. I'm going to go to the file and get it up so you can see it. You just need to run it again because I forgot to put PNG. And just bring this up. And here we are. So we have a nice snapshot ready to drop into an illustration somewhere. So we'll just go to Pop again. Remove that. Okay, that's nice. But we want to be able to do things like smooth, decimate, upsample, downsample, remove any isolated parts, subdivide, tell the difference between different surfaces. So what I'm going to do now is I'm going to use a function in RVCG called which is smoothing, and this is the same smoothing techniques that you can use in MeshLab. And it being R, we can do this for one file, but then we can also script this so you can do this to a whole directory. So the command is VCG. So VCG smooth is the thing. Now we're going to go for example skull. And I want default smooth skull. Okay, so if we go for a shade 3D, default smooth skull. We can see that this is generally more smooth. Okay, so it's just done a default smooth. But if I wanted to use, as you may already have read in journal articles, the best smoothing algorithm is considered to be the toe band smoothing algorithm for preserving features. So what I do, so I go VCG smooth. Example skull. And I'm just going to do 3 iterations. So if I just open a new window, I use the RGL open. I'm just going to label these. Visualizations. And here's the new RGL window, and I'm just going to and here we are, and we can see that it's preserved quite a bit more in terms of detail. Now, there's quite a bit you can do with RGL in terms of changing your lighting and where the lighting's shining from and so on. So it's well worth delving into the commands if you to improve your grasp of what can be done, so you can make even better illustrations. One thing that is quite useful in the default for RGL is if you hold down the right mouse button, it will change your perspective. So you can see this on the right hand side of the screen. It's really changing the perspective of the skull. So you just need to be careful that whatever perspective you use for your models, that you keep this consistent between them, because otherwise you can think that there's changes in shape when really it's just changing in perspective of the same models. We have a look here how the change in perspective can alter what you think a face looks like. Okay, so that's something to be really aware of. So we have this skull, and we've done some shading, we've done some different shading techniques, we've done some different smoothing techniques. Just going to close those two windows, because what we're going to do now is we're going to decimate the skull. And we're going to go for example skull. We're going to go %, 25%. And the percent must be between 0 and 1, so we make it 0.25. As you can see, even experienced users do sometimes forget the commands. So this takes it a minute or two. Now, I'll explain. My machine has 8 cores, 6 GB graphics card, and also a 32 GB of RAM, and I'm running on a fast solid state drive. So what you can see running here may not be replicable in speed on a basic laptop. This is a dedicated workstation. So your exact speed of manipulating things will be very dependent on the graphics, memory, and processor available in your desktop. Right, so let's have a look at this decimated skull. So let's have a look. Here we are. So we see this decimation hasn't done a huge amount to it. So let's try. So I'm just going to copy this. And I'm just going to change it to 5% of triangles. Whilst that's doing it, I'm just going to going to remove that, and then we'll go for it. As you can see, I've managed to miss one of the speech marks in it, which will mess up the command. Let's have a look at this. And we can start to see it's breaking down somewhat. What I'm going to do is I'm going to go for a 1%. So now I'm going to show you how you can get it to run some things straight after each other without you having to do it, so having to type all the time. So what I'm going to do is tell R to remove the viewer, decimate the skull down to 1%, and then show it to us. So let's go. Remove the skull. Now decimating it. So it's only going to have 11,500 faces. So it should show quite blocky now. And here we are. So we can see that that's quite blocky. If we remember what the original one looked like. That you can see it's quite blocky in comparison. So that's nice. So I've got this really blocky skull, and we want to see how badly the decimation affects the quality size. So what we're going to, and whether it changes where things are relative to each other. So in Morpho, if I open the help for Morpho, there's a nice function which does the surface distance. Which is mesh dist. So what you do here, so as you go on, and we would say this has a nice example. So we're just going to take the defaults from, and I'm going to go example skull. Okay, we're going to run that. Now there's an error has come up because R doesn't accept a variable name with a number at the start. So just going to change that variable to name. Now we run it. It's got a extra bracket. We remove that. As you can see, there's always going to be an error if you're not careful. Here we are. What we can see using a blue to red symbol thing is that the distance is quite significant around the teeth, which we expect because they're quite blocky, and then around some of the parts of the palate. Green is where it's exactly the same. And it's really useful for visualizing differences between similar meshes or different individuals. And what we have in the 1% distance is we have different things. So we actually have a list of the distances over the 1,000. Well, it's actually got 60,000 coordinates where it's measured the distances between the two meshes which are aligned to each other. So that's nice, and it's quite a nice little feature. So let's do something quite interesting. So we've got this mesh which we've downsampled to 1%. What we're going to do now is we're going to upsample that mesh to original using a thing called mesh subdivision. So VCG subdivide. And we are going to do this. So that is and we're just going to go for 10 iterations to start off with. So if we close all of RGL, let's go look at the difference between these skulls. So I've had to pause recording in between because it took it a little while to have a think, but everything's behaving now. You can see that the original skull in violet and the newly decimated skull in a light blue, and you can see it really didn't cope very well with around the teeth, for example. You can see it's really, so you have to be careful with upsampling and downsampling of meshes, that if you're using an overall decimation or upsampling, it may actually create false geometry in your meshes. So that's something to be really aware of. There are two more functions I want to show you before I then move on to how do we get these things into manipulating a whole folder. And what I'll do with that is I'll just show you a script that has been written by me to manipulate whole folders all at once, and we'll modify it slightly so you can see how it will change what there is. So what I'd like to show you now is two things. One is called removing isolated pieces in a mesh, and this is quite good when you have some scanner data where there may be a bit of noise, or maybe some micro CT or CT data where you've got some internal geometry that you want to get rid of. So there's two ways of going around it. First is to remove isolated pieces or split into components. So I'm going to use the example of the spinal column that I have in this file set for that, and then the second one is to just have a scan where you can only see the external geometry, and this will be using a function called virtual mesh scan, written by Stefan Schlager and Antonio Profico. So the first one we're going to have a look at is the isolated components, but we need to get the spinal column in so you can have a look at this first. So spinal column, file to mesh, column, X, now actually I've done this with some colours, so that would just bring it in as plain. So if I was to go redo spinal column, this would just give us the default colour, which is black at the moment in RGL. So what we want to do is we want to change this to read color. So this will import the color of the mesh as well. And R has crashed. It's okay. So we'll just go to the workshop folder. And try this again. Have to load the packages. Okay, set working directory, and it doesn't like it. So we will avoid that. Okay, so what we want to do is have a look at the spinal column. And one thing I didn't tell you is that Morpho has a couple of nice preset colors for bone and skin. The one I find works nicely is the one called Bone 2. So Stefan has put in a couple of, is specified these colors so you can have. Good. I have loaded in a segmented scan of a spinal column, which from my Sketchfab. And one of the things in Morpho, which is really nice, that Stefan Schlager has done, is he's implemented a couple of default shading colours based on the bone and European skin tones. So we're going to show this spinal column using bone 2. So you can have a look. It's quite nicely segmented, if I say so myself. You can see all the different bones. So if you think there's 5 lumbar vertebrae, 12 thoracic vertebrae, and 7 cervical vertebrae, which makes a total of 24 vertebrae. What we want to do is try and split these into their own individual files nice and quickly. So what we have is a function called BCG so it is BCG isolated. So what this does is we can remove isolated pieces, and we can split something like this segmented spinal column into each of the vertebrae, hopefully. What this will mean is that we should have a new variable coming along. Spine split, which will have so we go split equals true. Equals 24. And if we look at the spine split, so the spine split is into these different meshes. So they have a double square bracket. So if I was going to say shade 3D, or we will find that we have one of the cervical vertebrae. And what you can do is you can go through these as a list. So if I was to go and you can see then if we go for so you can see that it's not necessarily in order. So you have to be a bit careful with your things. So what one can do with something like a spinal column is look to see where they are in the whole thing. So what we could do here is we could go spinal column, and you can suddenly see where each of these ones are in the column. Now you can see within these segmentations that there are small bits that are sort of kept from the internal surface. So if we think about one of these, I'm going to shade 3D this one as a transparent individual. So that is so if we look at this bone from the segmentation, there's some internal geometry that we really don't want. It can do things like mess up the morphometrics if you're doing automatic landmarking. So we want to get rid of this internal geometry. So luckily, we have a function in Morpho called virtual mesh scan. So this simulates a laser scanner or a structured light scanner just looking at the outside. So what you need is so we have to get our viewpoints. So what I always do is, so we're going for spine split 1. So what this has done is giving us a list of viewpoints. So if I go for viewpoints, gives us the coordinates of that. So that has given us 36 of the outside. Now what I want to do is go outer mesh, spine split 1 equals virtual mesh scan. I'm going to bring up the thing so you can see that we need to have spine split 1. Now we want to go view, and then I'm going to put all of my cores, 6 of my cores into doing this. The more cores you can throw at it, the faster it will do it. She's going to do this, takes a couple of minutes. You just go viewpoints, viewpoints. It'll take a couple of minutes. And it has done it. So if we go to shade 3D, visible, so we're going to pop that out. Two. In this final section, I'm now going to show you how to manipulate a whole folder of meshes and export all the snapshots as well as all the different variants of the meshes. So what we're going to do is we're going to use the same data set as before. So we've got the micro CT of trabecular bone, an example skull and an example spinal column, and we are going to load in the folder, and it's going to go through each of these, and it's going to clean up the file and save a snapshot, decimate the file, save a snapshot, smooth the file, save a snapshot, and then write the cleaned, the decimated, and the smoothed apply files out to the original folder. This is just a basic for loop, which is a very common way of programming. It's my preferred way because I can get them to work nicely. You can use another function in R called lapply, which is a little bit faster, but for most users, the for loop, if you're just doing a couple of iterations, like clean and decimate, is fast enough for most users. So without further ado, what I do is I highlight the whole script, and I press Control or Command Enter. It loads up R and it loads up RBCG. It asks me to browse for a folder. So I'm going to go to the folder that I set up for these meshes. So in here, and it starts to do everything as long as you have RGL involved. Okay, so we'll try that again. So navigate to the folder, which is the mesh workshop scans. Go through what it does. Bring over the device. You'll be able to see it's bringing up a snapshot each time, and in this folder in the documents, okay, so we are going to run through the script, which will manipulate the files. So it will clean them up and save a snapshot. It'll decimate the file and save a snapshot. It'll smooth the file and save a snapshot. And then it will write the apply file of the cleaned, the decimated, and the smooth one, all with a title that relates to the snapshot, into the original folder, because I've told it to write to use the mesh workshop scans folder as the default working directory. And we'll be able to see this happening in almost real time. So I'm going to just open up a nice window for you. I'm going to select all of the script, make sure you have morpho, RBCG, and RGL loaded. This command require, make sure that it loads them. And I'm going to highlight it, press Control Enter, and it will ask me for a folder. So I go to the folder, and what it will start to do, if I go to the folder, is you can see it's starting to write the snapshots and the manipulated files into the folder. So this is really helpful if you're doing lots of different individuals and you want to just have a quick reference. Say you're then doing pattern recognition and you want to split up the folder a bit more automatically or faster. So for example, if you're doing a folder where you've got clavicle, scapulae and humeri and you know you've got to just smooth and decimate the whole lot, and then it will allow you to do that quite nicely and export these with the snapshot. Means you can just go to the snapshots and make everything a bit easier to see, much easier to manipulate. So for example, I can see in this that I've got all the trabecular bones, so I can just go and make a new folder. The ROI. Then I've got all the ROIs in one folder. Just undo that. And you can see quite quickly, I can split the folder up a lot easier, which makes your downstream management of data a lot easier as well. So I hope you have found this workshop to be useful. It's not 100% comprehensive, but I do hope that you have found what I've done to be of use, and that you'll be able to maybe start using R to batch process your data for when there are simple things that just need fixing, rather than having to rely on commercial software. So thank you very much for your time, and I will leave you in peace.